Hello guys, today in this video we will be learning about two very important named reactions for the preparation of alkenes. Not only the method which is there for the preparation of alkenes are important, along with the name of these two reduction reactions, their limitations when these two named reactions actually fail, that also to be known as a competitive point. So let us learn. With that note, I would like to welcome you all to the today's chemistry session. Okay, so let us begin today's class. So I'll write the first reaction which must be learned today is Clemmensen's. Okay, Clemmensen reduction. So it is known as Clemmensen's reduction or Clemmensen's reaction. So what is this reaction, or what is this reaction is all about? It is about the reduction or reducing carbonyl compounds. So starting material for Clemmensen's reduction is carbonyl compounds. Carbonyl compounds are mainly of two types, aldehydes as well as ketones. So you can take any one of these two. So generally let us write carbonyl compound only the functional group. The other two valencies of carbon let be satisfied by either R group here, or one hydrogen and one R group, or two R groups. So when you write two R groups here, it will become ketone, and one R and one hydrogen, that will become the aldehyde. So what is reduction, isn't it? So reduction is nothing but addition of hydrogen or removal of oxygen. So both these two ways we can define, or with the help of both these two ways we can define reduction. Now what Clemmensen's reduction reaction is, it makes use of reducing agent given by Clemmensen himself. Okay, the reducing agent is zinc amalgam. Okay, and this zinc amalgam to be taken in the presence of concentrated HCl. So one more question it could be, the Clemmensen's reducing agent is zinc amalgam and concentrated HCl. Combination is called as Clemmensen's reducing agent. So what it does, it supplies hydrogen. Okay, so it supplies hydrogen. How many you require here? 4. Why? Because H2O to be removed and 2H2 to be added, so 4 hydrogen atoms. So I can write in terms of molecule, 2 hydrogen molecule. So what happens now? The functional group carbonyl, which was originally in the reactant side, now gets converted into alkene. So this is your alkene. And what about this? This is carbonyl compound. Okay, carbonyl compound. So our carbonyl compound is converted into alkane with the help of Clemmensen's reduction or reducing agent. Now what is the byproduct? H2. Is that fine? So this is how we have to, or we rather convert the carbonyl compound into alkane. One of the method, and very important, let me tell you, Clemmensen's reduction. Zinc amalgam we call this because amalgam are the compounds with mercury. Okay, mercury is known as amalgam. So zinc mercury combination is known as zinc amalgam. Similarly, we have sodium amalgam, magnesium amalgam in different reduction reactions. Fine. So now let us understand when actually this reaction can be used, or when we are not supposed to use this particular reaction. Okay, so let us see that. This is, to be precise, a very important competitive exam point. Okay, so let me write it. This particular reduction reaction fails when there are carbonyl groups along with the carboxylic group. Okay, so two functional groups are present. Which of them? One supposed to be carbonyl, we know. The other along with carbonyl, if carboxylic acid group also present, this reaction cannot reduce carboxylic, or this particular reducing agent cannot reduce carboxylic group due to resonance. That's it. And also when double bond is present along with the carbonyl group, the double bond will be retained. So let me write those two important points. Okay, first one, let me take the example of this. Here I have a ketonic group like this, and this is my carboxylic group, isn't it? C double bond O OH. So CH3, C double bond O, CH2, COOH compound. So this exactly fit into our condition now. Okay, carbonyl along with the carboxylic group. When I carry out this reaction in the presence of zinc amalgam, fine, concentrated HCl, of course, which will supply hydrogen. So obtained product is this double bond O and OH. Did you observe now? The carbonyl carbon atom now reduced to, see, if I don't write anything here, it understood that it is CH2. Okay, carbonyl carbon is got reduced, however the carboxylic acid is retained. So valid or very important point. Also, one more example if I take for double bond like this. Okay, so I have here double bond and H. What is this compound? CH3, CH, double bond CH, CHO. It's aldehyde group. So under similar conditions, that is zinc amalgam, hope you are following, concentrated HCl. Okay, so what happens? The double bond will be retained in the product. So this is your product like this, isn't it? So I have CH3, here CH, CH, and this entire CHO will become CH3. So here CH3. So therefore, these are the two important points to be remembered. Also, the one more important point is that whenever the compound has got acid sensitive groups, this is very important, asked in previous year papers, especially AIMS examinations. Okay, whenever acid sensitive groups are present, what are acid sensitive groups? Like hydroxy groups, OH, right? Also the keto groups, sterically hindered, so we call it as sterically hindered keto groups, or even the substrate molecules with large molecular mass or weight. So in such cases, Clemmensen's reducing agent is going to fail, or this reaction fails. So let us understand that with one more example. So I'll take the example of cyclic ketone, dear students, here. Okay, so this is it. I have a here C double bond O CH3. Did you understand? Now it's a ketone along with the acid sensitive group. Let me substitute OH. Very important this example is, or these types of examples. Now cannot reduce. Let me write in sentence. Okay, it cannot be reduced. Okay. To what? See, our expectation is OH to be retained and this has to be converted into CH2, isn't it? As per the reduction process. So, but what happens is, it cannot convert the taken compound or reactant into, I'm sorry, here, let me write as a CH2 and CH3. Okay, so here OH. So, this process cannot be done. So cannot be reduced into this compound. Why? Because prior to the aldehydic or ketonic group or so-called carbonyl group, OH group will be reactive towards the concentrated HCl. You know, elimination reaction or OH minus acid sensitive, those are nothing but bases. Base will react with acid to form a salt. As a result, this reaction cannot go in this way. So this cannot be done. Or even the strongest reducing agent called red phosphorus hydrogen iodide in a concentrated condition, this combination also cannot be used because it's a strong acid HI, which cannot reduce this. Why? Because it will react with the base. So these things to be remembered. Then how to convert this compound into here, whatever written product? There is a method. For that we have to go for one more reduction reaction. Which is that? Yes, we will be writing it now. The second one here, that is Wolff-Kishner reduction. Okay, please remember the name. You pronounce in your own way, no issue, but write the proper spelling and remember it. Wolff-Kishner reduction. Fine. What is this reaction? And it is also similar to this Clemmensen's reduction. Conversion, that is reactant and products are going to be same, but pathway or route of the reaction is going to differ. We have same reactant starting point, we have same product the end point, but the path in which this reaction progress, no, that is different. So in what way it is different, let us understand now. So in this particular reaction, what we are doing is we are taking the similar compound, that is carbonyl group only. Okay, so let me write it as a carbonyl group, carbonyl compound or group. Okay, compound which must be initially treated with hydrazine. What is hydrazine? It is nothing but NH2 group. okay, NH2 hydrogen and nitrogen combination, diamine group, okay. So NH2 is called as hydrazine, which is the first step of your Wolff-Kishner reduction, okay. Hydrazine is taken. What happens? It's a typical example for nucleophilic addition reaction. So nucleophile, it acts as a nucleophile and it adds to the carbonyl group. So how it is? Along with the elimination of a stable product, water. So in this way it is going to add. So obtained compound is called as hydrazone. Whenever carbonyl groups reacts with hydrazine, corresponding hydrazones are going to be formed. So as a result, the obtained compound is here C double bond N NH2. Hope you can understand this particular reaction path, how it is going to proceed. So this is known as hydrazone. Okay, it depends, the name depends on the compound which you take here. If you take acetone hydrazone. If you take acetaldehyde hydrazone. In this way the naming can be done. Okay, going ahead. Now this particular hydrazone formed is going to lose nitrogen in the form of dinitrogen. So what is our intention, you tell me? We have to convert this carbonyl group into hydrocarbon alkane. So for that, what should I have now? This nitrogen molecule to be removed. So when you remove this, H2 will be added up here. We will get the same product which we got in Clemmensen's reduction. Did you get that? So as I said earlier, the reactant same, product is also going to be same, but the conversion or the reagent is different. That's it. So in order to remove this nitrogen, we are supposed to heat at high temperature. For that, the solvent to be selected. Why? Because when you heat to high temperature, solvent should not get evaporated, no? Isn't it? So its vapor should not be formed at the given temperature range. So high boiling point liquid to be selected, and that is dihydric functional group compound, which is ethylene glycol, or generally we call glycols. So all glycols are having two OH groups, therefore they are strongly involved in hydrogen bonding. Easily you cannot vaporize these compounds, or at a normal temperature, in the sense normal temperature required for the reaction. I'm telling, it's not room temperature what I wanted to tell here. Okay, fine. So what I do is I treat this with KOH, potassium hydroxide, in the presence of high boiling point liquid called glycol. So ethylene glycol to be selected, or any glycol. I'll take here ethylene glycol, and let me heat around the temperature range of 150 to 200 degrees Celsius. So when I heat this to that temperature, the nitrogen will get escaped or expelled from the compound. So as a result, you will get it as C. Okay, so H2. This is what our alkane, or our intention, alkane is formed. So in this way, we can prepare, or we can get alkane from the Wolff-Kishner reduction. So these are the two pathways, dear students. Now, what is the disadvantage or problem with Wolff-Kishner reduction? This reaction fails because we are taking base here. Here we took acid, therefore acid sensitive groups cannot be reduced, whereas here, since we are using base sensitive groups if present in this reaction or in the reactant side, obviously this reaction is going to fail. So in such cases, what we supposed to do? We have to go for Clemmensen's reduction. Is that okay? So with the help of these two reactions, we can convert any given carbonyl compound into alkane. So what did I say here? Base sensitive groups are going to be, or they are not going to be reduced with this particular reaction. One example, if you want, you can take this as a base sensitive group, okay, or base sensitive compound. Here C double bond O, a slight change or modification, what we call, I'll do here with respect to the compound. Here in this position, okay, opposite to that of functional group, here OH is there. Now let me take halogen, iodine. Iodine is a very good base sensitive. I mean, it is very quickly will react with base. It will have the tendency to remove or to come out as potassium iodide. As a result, base sensitive halogens or even heavily substituted ketones are base sensitive. As a result, you cannot take this compound in or during Wolff-Kishner reduction. If you take it, what happens? You won't get the desired product. See, our intention both the reactions to convert the functional group carbonyl into hydrocarbon, not to disturb the other attached atoms or groups. So thereby if you take this compound, it cannot reduce, okay, cannot be reduced to is the compound, let me write the product, CH2 CH3, okay, I. So this iodine containing compound cannot be obtained if we go for such type of conversions or reaction. So here the suitable conversion is or reagent is Clemmensen's reducing agent. So in this way, by interchanging we can prepare any type of alkane, or rather we can convert any type of carbonyl compound into corresponding alkanes. Got it? So these two are very important for your competitive examination. Hope you understand, you follow these reactions, okay. Prepare well again, as I always say, for your competitive exams. That's it from this video, dear students. So we'll meet in some other concepts. Thank you.